So the next two sections are all on similar triangles, and this little symbol means similar to. So basically what you're doing is you're proving that two triangles are similar, and we have to understand what the word similar means. So I'm telling you right now that triangle ABC is similar to triangle DEF. They are not the same, right? They're not equal, because just by looking at it, I just drew a quick sketch. Just by looking at it, you know they're not the same size, right? But what does it mean if they are similar? If the corresponding, this word's important, if the corresponding angles are equal, it means they're exactly the same, and the corresponding sides are proportional, then they will be similar. If they're proportional in length, I should say. Okay, we have to prove that. We have to figure out what does that mean. Well, angles, easy. If the angles are equal, then the triangles are similar. Also, if the sides are proportional. So, corresponding, does anyone know what that means? What that means is that if they're in the same position, okay, that's what's important. If they're in the same position, you're going to learn in this chapter that sometimes the images will be drawn differently, and we're going to rotate them to draw them in the same position. So for example, if I tell you that this angle is 30 degrees, which angle it would be equal to 30 degrees if these triangles are similar? Which angle has to be equal to 30 degrees? D. Okay? So if I tell you that angle C is 70 degrees, which angle must be equal to 70 degrees if these are similar, if it's true that they're similar? Yep. F. And quick little review from grade 9. The sum of the interior angles should add up to what? 180. So if this is 30 plus 70 is 100, angle B has to be 80 degrees, right? If angle B is 80 degrees, which angle is also 80 degrees? E. Straightforward. If the corresponding angles are equal, that's one indication that the triangles have to be similar. But it has to be both of these. The corresponding angles have to be equal, and the corresponding sides have to be proportional in length. So what does that mean, proportional? Let's pretend that this side length is 10 centimeters. And think of an image. I blew this up. Let's say I blew it up by 2. What's 10 times 2? 20, right? Which side length has to be 20? Which side length corresponds to that side length in the second triangle? DF, right? Can everyone agree that this side length, AC, corresponds to DF? They're in the same position. So if I increase 10 by 2, that would be 20 centimeters. I have to increase every other side length by the same amount in order for it to be proportional. So I'm just going to make up numbers. Let's pretend that side AB is 12 centimeters. Which side length corresponds to AB? Which side length in the second triangle is in the same position as AB? Raise your hand. Good. This is in the same position. So if I know that I'm increasing this, I'm multiplying it by 2, okay, they have to be proportional. I have to multiply it by the same number in order for them to be similar. So what am I going to multiply this by? 2. What's 12 times 2? So this side length has to be 24. So far, you understand what I'm doing? I'm going to make up another number here. Side length BC corresponds with EF. So let's pretend that this is 15 centimeters. If this is 15 centimeters, how would I make sure that that triangle is similar? It has to have the same proportion. So what did I multiply everything by?
2.
So what do I need to multiply this by? So that would be 30 centimeters. So we're trying to check to see if these two triangles, triangle ABC, is similar to triangle DEF. So this is basically your checklist. Are the angles equal? the corresponding. You always have to make sure that you're looking at the corresponding angles. So again, if they're in the same position, then they're corresponding. This angle corresponds to this angle. So angle A corresponds to angle D. Are they equal? Are angle A and D equal? Yes. Angle B corresponds to which angle? Okay, are they equal? And then angle C corresponds to angle F, and they are equal. So that's the first thing on our checklist. If the corresponding angles are equal, we know that there's a possibility that these are going to be similar triangles. The other thing we need to check is that the sides are proportional. So let's prove that right now. So we're going to use the colors again. AC corresponds with what? DF. So I'm writing it as a proportion. So I want you to write it like this. Okay? AB corresponds with DE. Okay, so let's write AB over DE. These are the sides that are corresponding. We're going to check to see if all their ratios are equal. And then BC and EF. Let's fill in the blanks now. What was the side length of AC? What was AC? 10 over 20. What is AB? Was 12 over 24, and BC was 15 over 30. We need to prove that these are equal. If they're equal, it means they're proportional, right? Just by looking at this, do you think that this is showing a proportion? Let's calculate it. What's 10 divided by 20? 0.5. What's 12 divided by 24? 0.5. What's 15 divided by 30? 0.5. So in our checklist, we had to make sure that the angles were equal and the corresponding sides were proportional. This proves that they are proportional. If all of their ratios are equal, it means that it was either increased or decreased by the same amount.